Hello, my name is Stuart Williams, and this is the first in a series of videos about Azure. In this video, we'll introduce the fundamental triplet of triplets, which is all about how the cloud works. Let's get started. First, what is a cloud? A lot of things these days get called clouds, and in fact, any large distributed workload could be an argument for a cloud, but it's important to think about what makes a general purpose cloud, which is what Azure is, and other cloud competitors to it, what they are. So fundamentally, it's the following list: pay-as-you-go pricing, infinite resources, or for all practical purposes, infinite resources, easy tooling to scale vertically or horizontally, very high availability and durability, the availability of infrastructure, platform, and software as a service, and the ability to provision infrastructure on the cloud using desired state configuration, or DSC, sometimes called infrastructure as code, or IAC. And that's the ability to, from a script, build up an entire environment. If something's going to be called a cloud, at least a general purpose cloud, they should pretty much conform to most, if not all of these. Of course, Azure does. One way to think about Azure is as a triple of triplets. From bottom to top, we have the hardware tier, the middleware tier, and the services tier. So let's explore each of them one at a time. At the hardware tier, we have the fundamental triplet of what it takes to have a computing platform, along the classic Turing and von Neumann definitions. Computing and storage, that's the original Turing model. That is that idea of a tape, so to speak, the modern version. And the von Neumann model, which says that computing and storage can be connected. Fundamentally, Azure has low-level components that do networking, compute, and storage. The middleware tier is about command and control for the most part. When you issue commands to Azure, either through the portal or through one of the command lines, what you're doing is giving commands to the RDFE, some of which are executed by the Fabric controller, and then whatever you asked for is provisioned. Many of the services that run in the tier above run on Azure App Fabric. The hardware triplet is where things actually get computed, and it's comprised of the following components: compute, which are CPUs, GPUs, and RAM. Those two things are often frequently coupled tightly together because of the interaction between CPUs and GPUs in the RAM. And storage, which can be either solid state or spindle driven. And then lastly, networking. Not just the physical wire or fiber connections, but all the things that go with networking: switching, firewalls, security appliances, load balancers, and all that stuff. FPLAs allow you to make network appliances and other things on the fly. In other words, you can take a chunk of FPLAs and turn it into a firewall or an appliance or a router or a switch. And they can operate at very high speeds, higher than most traditional server-based, classic server-based platforms. And so we're a lot more performant, and in this case, a lot more flexible. The middleware triplet is the command and control layer for Azure, comprised of the Red Dog front end, the RDFE, and the Fabric controller. The RDFE manages Fabric controller instances and allocates resources so that when you go to play your provisioning script at Azure, the Red Dog front end will get your script, and it is part of the engine that drives your desired state configuration. In other words, it's what helps figure out if you say, I want 3 virtual machines and an Azure SQL instance and a Cosmos DB and a set of load balanced application hosts. It's the one that figures out the difference between what you have now and what you need to have, and creates whatever, or orders the creation, more exactly, the creation of whatever resources you've asked for. In other words, it oversees the provisioning, and the Fabric controller manages the low-level implementation of many of those tasks. The other thing that's middleware is the Azure App Fabric. Increasingly, a lot of Azure's own infrastructure, in terms of infrastructure as a service or platform as a service, things are built on Azure App Fabric. And in fact, many SaaS vendors build on top of Azure App Fabric too, because as we said before, it provides security, caching, high availability, scalability, interaction, and everything else that you would need to have one set of components talk to another. And so it takes a lot of the pain away from making your own platform as a service or software as a service offerings. And again, many of Azure's software as a service and platform as a service products are built on top of the Azure App Fabric. And lastly, we have the services triplet, which again is the part that you normally think about and interact with when you're building out a solution to run on the cloud. Here's the classic diagram that helps illustrate the difference between infrastructure as a service. So that would be virtual machines, that would be containers like Docker, Docker Swarm, or Kubernetes, that would be the actual networking, and any other plumbing pieces. And the light blue bits are the bits you have to build or supply. Although in the case of infrastructure as a service, I'll point out that virtual machine libraries and libraries of containers will often deploy everything except the data for you. In other words, you can ask for a Microsoft SQL Server virtual machine, and it'll lay down an OS, it'll lay down SQL Server, it'll lay down some application components, and voila, you just add data and you've got an IIS version of a SQL Server. For containers, you can say, hey, I would like Ubuntu, Linux container system, and I would like you to put support for Node on it and NPM, and then you would deploy your own containers that have your Node applications that run on it, right? So instead of having to build those things from scratch, you can pull them from a library. And so the OS database and application tier may be part of a CAN library, but they are part of a disk image that sits on top of the other four things, that is to say the data center, the network and storage, servers, and virtualization. For platform as a service, we abstract away the need to know or care about the operating system. In the case of a data-oriented thing like Cosmos DB or Azure SQL Server, that part is already configured for us for the most part. And you need to add only your own application bits and data. So on, for example, an Azure SQL Server, that would be your tables, views, stored procedures, and then the population of data in them. Same for Cosmos. For other platform as a service components, there is no, quote, database tier other than configuration. You can think of application service hosting up in Azure as having, quote, a database, unquote, of configuration that keeps track of all of the different applications that you might deploy onto a particular host. And it keeps track of the scaling and so on. And lastly, there's software as a service, which is turnkey components ready to use out of the box. There are plenty of those in abundance, whether they're for data analysis, ERP systems, CRM systems. If there's a kind of software that are used by businesses, there's a fairly good chance that the vendor will have provided a software as a service version. In all cases, the Azure Marketplace has huge collections of different facilities in the infrastructure as a service, platform as a service, and software as a service categories. So how do you make sense of the enormous surfaces that most clouds have? Most clouds have a bewildering array of choices with names and features and pros and cons and a whole list of information they have about them. But the easiest way to think about all of this melange of things is to think about capabilities. Here's my little checklist of things. And I'll point out that a particular component, for example, Azure SQL, could fulfill a number of these. It's capable of doing compute. In other words, you can run scripts in it, right? In the case of SQL, it's SQL stored procedures and even components that are running in .NET. It's a relational database. There's a storage behind it. SQL Server has queues that SQL Server has a scheduler, and so on. If you were to take this list of capabilities and use it to look at a particular component that you would see in a cloud. By the way, this works with more than just Azure, and put it into these capability categories, then you could start to define what part of the solution space a particular component might be suited for. And then, for example, if you're looking for a place to put data, that would allow you to do apples to apples comparisons of relational databases versus NoSQL databases versus pure storage things or queues or whatever. And I find for myself that if I do abstract architectures and say, well, I need a storage, I need a queue, I need a place that does work, I need front end, I need interoperability with some third party, and so on. If I chart that out and then I think about the different things that Azure or some other cloud offers, and I puzzle piece those together in the context of this capabilities list, I can very quickly make decisions about which particular component of the many choices I might have best fulfills my requirements. And I'll point out that the folks at Microsoft Azure team are doing a great job of consolidating many things into as sort of few entry points, if you will, as possible. For example, Azure Logic Apps have now subsumed some of the BizTalk in the cloud features and is a good general purpose workflow engine that suits a whole bunch of different scenarios. And so if you know that you need workflow, particularly message-based workflow, it's a pretty great choice. In the same way, if you need large-scale data movement and transformation, Data Factory is a pretty good choice. And you can think of the premise equivalents of those being on the messaging side. You might think of it as Workflow Foundation in .NET, or something like a TIBCO that does message handling and processing. And on the data flow side for Data Factory, you might think about equivalent things like SSIS for SQL Server that's designed to do data movement and transformation. Here are the icons for the most common components that are used in solutions built in Azure. And I included a link, and you can go and see this map actually clickably up on the web. It changes as they add and remove things and upgrade things and so on. And you can go and explore the components, but as you do, think about them in terms of the capability slide I had before. And I think you'll be able to very quickly understand the intention of each of these capabilities and how they might fit like puzzle pieces into your overall architecture to be able to execute the desired system. My name is Stuart Williams, and this was a speedy, quick overview to the triple of triplets and how Azure works.